is we need to find the Fourier transform of f of x when f of x is equal to 1 minus mod x when mod x is less than or equal to 1, and it is 0 when mod x is greater than 1. And also we need to deduce that from the integral 0 to infinity sine square t by t into dt is equal to pi by 2. Okay, so here we should not evaluate, we should not find this value. They have already given the value for this. We need to just prove that it is equal to pi by 2. But the procedure remains the same. First we need to find f of s, after that we need to find the inverse Fourier transform, so that this value remains the same. So first now we need to find the Fourier transform. Okay, yeah, so I have directly written the substitution, that is from the integral from interval is from minus 1 to 1, since the mod x is less than or equal to 1, right? So the interval is from minus 1 to 1, and I have told it right, the previous intervals, that is minus infinity to minus 1 is not mentioned, and the interval from 1 to infinity, that is x is greater than 1, the function f of x is given as 0. So those two terms, intervals, will be neglected. Only this term would remain, and the given f of x here is 1 minus mod x. But as per the definition of mod x, we have two values for mod x. Mod x can be x as well as minus x, right? So in the similar way, we need to write the intervals as well. Okay, we know that mod x is equal to minus x when the value of x is negative, that is when the value of x lies between minus 1 to 0, right? The value of mod x is equal to minus x e power isx into dx, and the value of mod x is positive when the limits are from 0 to 1. So I have just splitted the limits in this case, like I have written it as from minus 1 to 0 and also from 0 to 1 in order to satisfy the definition of the mod. Okay, so here the mod is positive 1 minus x into e power isx into dx. Okay, so now for this we need to solve. Minus 1 to 0, minus into minus is plus, so this is 1 plus x into e power isx into dx, plus 0 to 1, 1 minus x into e power isx into dx. Okay, so now we need to apply the Bernoulli's rule, okay, for this function as well as this integral. So now we'll apply the Bernoulli's rule. First function as it is into the integration of second function e power isx divided by is minus the differentiation of this function, that is differentiation of 1 is 0 and x is 1, into e power isx divided by I square s square. The limits are from minus 1 to 0 plus first function as it is into the integration of second function minus the differentiation of this function that is equal to minus 1. Differentiation of minus x is minus 1, right, into the integration of the integrated function. The limits are from 0 to 1. So now the f of s value is, the upper limit is 0, so 1 plus 0 is 1 into e power 0. The value of x is 0, so the power term will become 0, divided by is minus 1 into e power x value is 0, right? So when we substitute the value of x is 0, so the whole power becomes 0, divided by I square s square minus the lower limit, that is 1 plus minus 1, so 1 minus 1 is 0, so this whole term will become 0, minus e power minus is, since the value of x here is minus 1, divided by I square s square, plus, now for this again the upper limit is 1, so 1 minus 1 is 0, so the whole term becomes 0. I will not write that again. So in the second term, minus into minus is plus, so e power value of x is 1, so it becomes is divided by I square s square minus the lower limit, that is 0, 1 minus 0 is 1 and the value is 0, so it is e power 0 by is. It's actually 1 into e power 0 by is, so 1 minus 0 is 1 and the value of x here is 0, so this becomes e power 0 by is plus, again minus into minus is plus, e power 0 by I square s square. Okay, so now we'll align the terms, we'll remove all the brackets and we'll write it in a single line. So we know that e power 0 is equal to 1, so I'm going to write it as 1 by is minus 1 by I square s square, minus into minus is plus, so e power minus is divided by I square s square plus e power is divided by I square s square, and again there is a minus sign, so this becomes minus e power 0 is again 1 divided by is, minus into plus is minus, e power 0 is 1 by I square s square. Okay, so here we can cancel 1 by is and minus 1 by is. Okay, so the required f of s now is equal to, so here wherever there is I square, substitute it as minus 1. Okay, so when we substitute this as minus 1, so the sign changes to positive, so this becomes 1 by s square, right? And here from positive this becomes negative, e power minus is divided by s square, again this is minus e power is divided by s square, this becomes plus 1 by s square. So here we can see that 1 by s square, 1 by s square are adding up, so this we can write it as 2 by s square minus e power minus is by s square minus e power is by s square. So here in these two terms 1 by s square is common, and take that 1 by s square outside. I'll take minus 1 by s square outside, and the remaining terms are, if we take minus 1 by s square common, are e power minus is plus e power is. I have taken minus 1 by s square common, right? So plus e power is will be remaining. So now again this is of the form of cos, right? So since e power minus is plus e power is divided by 2, right, in case of cos, so again for this term we need to multiply and divide by 2. So the final answer will be looking like this: 2 by s square minus, if you multiply the numerator by 2, it will be a 2 cos, in place of theta, that is there is s divided by s square. Again in these two terms 2 by s square is common, take that outside, 2 by s square into 1 minus cos s. Okay, so we can keep this as the final answer, but so that in order to show that the question is, we need to reduce that sin square t by t is equal to pi by 2, right? So you can even further simplify the f of s here. So we have an trigonometric identity formula, that is 1 minus cos theta is equal to 2 sin square theta by 2, right? The same thing I am going to write it here as well, here also, that is 2 by s square into 1 minus cos s is equal to 2 sin square, in place of theta there is s, so s by 2. So the final answer of f of s would be 2 into 2 is 4, 4 sin square s by 2 divided by s square. So this is your required f of s. Okay, so now by using this f of s we are going to deduce the case which is given in the question. So now we need to use the inverse Fourier transform. Okay, we know that the inverse Fourier transform is given as f of x is equal to 1 by 2 pi minus infinity to infinity f of s into e power minus isx into ds, right? So now here substitute the value of f of s, minus infinity to infinity, the value of f of s which we have got is 4 sin square s by 2 by s square into e power minus isx into ds, right? So now again, we know that we need only the sign terms, right? In order to prove, we don't need this e power term. So how to eliminate this? We have done previously in one problem. That is, we need to eliminate this by putting the value of x is equal to 0 in this whole equation. That is, this, if we put the value of x is equal to 0, so this would be e power 0, that is equal to 1. So this term will get eliminated. Yeah, so the same thing we are going to do it here also. We need to put the value of x is equal to 0. So this f of x would be equal to f of 0, and f of 0 is given as 1. How is f of 0 1? So in the question it is given that 1 minus mod x, right? F of x is equal to 1 minus mod x. So substitute the value of x here. X is 0, right? So 1 minus 0 is equal to 1. So the f of 0 which we get is equal to 1. So now we'll write it. This becomes f of 0. F of x is replaced by f of 0 is equal to 1 by 2 pi into minus infinity to infinity 4 sine square s by 2 by s square into e power 0 is 1, right? So I am not writing it again. So now f of 0 is equal to 1 upon 2 pi. So now this, again the same thing. In order to replace the limits by 2 times 0 to infinity, we need to check that whether this is an even function. And most of the time this should be an even function, okay? So now let's check that. That is, we need to take f of minus s, that is 4 sine square of minus s by 2 divided by minus s the whole square. That is equal to f of minus s is equal to sine square of minus s by 2 is always equal to sine square of s by 2 itself. It will not be equal to minus. So this is equal to sine square of s by 2 itself divided by minus s the whole square is equal to s square. So this is equal to f of s only, right? So that we can say that it's an even function. So now we can write the limits as 2 times of 0 to infinity into the given function, that is 4 sine square s by 2 by s square into ds. So now here again we can cancel some terms, that is this 2 and 2 gets cancelled. So the remaining terms are 1 upon pi 0 to infinity 4 sine square s by 2 by s square into ds. But we have not reached the solution. So in order to, in the deduction case here, in place of s by 2 there is t, right? There is t, right? So we are going to do the same thing here also as well. We are going to replace the value of s by 2 is equal to t, okay? So put s by 2 is equal to t. Now cross multiply this 2 to the other side, so this becomes s is equal to 2t. So now we need to differentiate on both sides, that is differentiation of s is ds and differentiation of 2t we can write it as 2 into dt, okay? So these values we are going to replace here, okay? So this equation would be now 1 upon pi into 0 to pi 4 sine square s by 2 is equal to t, right? Divided by s square is equal to 2t, s is 2t, right? S equal to 2t, so s square equal to 2t the whole square, and in place of ds now it is 2 times dt, right? So now 1 equal to, so bring this 2 is there, right? Bring it outside, so this will be now 2 by pi from 0 to infinity 4 sine square t divided by 2t the whole square is equal to 4t square into dt. So cancel this 4 and 4, so the remaining terms are 1 is equal to 2 by pi 0 to infinity sine square t by t square into dt. So now we have completed 90% of the problem. So now again cross multiply, bring this 2 by pi to the other side. So now the required answer which we are getting is 0 to infinity sine square t by t square into dt is equal to pi by 2. I have taken 2 by pi to other side, I have just cross multiplied. Yeah. So this is your required answer. We have proved it, that is hence proved. So this is the next question, that is we need to find the Fourier cosine transform of f of x. The same way we have 3 set of values for f of x, that is f of x is x when x lies between 0 to 1, and it is 2 minus x when x is between 1 to 2, and it is 0 when x is greater than 2, okay? So fc of s is given as 0 to infinity f of x into cos sx, right? It is Fourier cosine transform, so cos sx into dx. Again we need to split the limits, that is we need to write it as fc of s 0 to 1. In 0 to 1 the value of f of x is x cos sx dx, plus from the interval 1 to 2 minus x cos sx into dx. So from the interval 2 to infinity the value of f of x is 0, right? So I am not writing it again. So for these two we need to solve. Apply the Bernoulli's rule. First function into the integral of second function. Integral of cos is sine minus the differentiation of x is 1 minus cos sx by s square. Limits are from 0 to 1 plus 2 minus x as it is. Integration of cos is sine minus of differentiation of 2 is 0 and minus x is minus 1 minus cos sx by s square, and the limits are from 1 to 2. So now apply the limits. So first the upper limit is here 1, so it is 1 into sin s by s, minus into minus is plus cos s by s square, minus the lower limit that is 0 into sin 0 by s, minus into minus plus cos 0 by s square, plus for this the upper limit is 2, so it is 2 minus 2 into sin 2s by s, minus minus plus, and plus minus is again minus cos 2s by s square, minus the lower limit that is 2 minus 1 is 1, so I am writing it as sin s by s. Here the value of s is x is 1. Since 2 minus 1 is 1, it is actually 1 sin s by s. I have written sin s by s minus again cos s by s square. Okay, so now let's eliminate these brackets and we'll put it together now, all the terms. Before that we can cancel some terms, right? Here, so 0 into anything is 0, so this is 0. 2 minus 2 is 0, so this whole term becomes 0. So the remaining terms are sin s by s plus cos s by s square, minus plus is minus, and cos 0 is 1, right? So minus 1 by s square, plus into minus is minus, so minus cos 2s by s square, again minus sin s by s, minus into minus plus cos s by s square. We need to be very careful while writing the signs, okay? If there are brackets outside, please check the signs as well, because those are very confusing part. You might get the wrong solution and you might lose the marks, okay? So here we can cancel sin s by s and minus sin s by s, right? And we can add cos s by s square and cos s by s square. So the remaining terms here are cos s by x square plus cos s by s square is equal to 2 cos s by s square minus cos 2s by s square minus 1 by s square. So here we can see that 1 by s square is common for all the terms. Take that outside and the final answer which we get is equal to 1 by s square into 2 cos s minus cos 2s minus 1. So this is your required answer. So the question goes like this. We need to find the DFT of sequence 3, 4, 5, 5. This is the sequence given. Also we need to find its inverse DFT obtained from the signal. So first we need to find the discrete Fourier transform of the signal given. After that, whatever the answer we got, right, using that we need to find its inverse discrete Fourier transform. So can anybody tell me what would be the inverse discrete Fourier transform that we should be getting? So the inverse Fourier transform that we should be getting is this itself, okay? So after whatever we got the answer while solving the discrete Fourier transform, when doing the inverse, the resulting answer we should get is this set, okay? If we did not get this set, then we have done the mistake, okay? Yeah, so now we'll solve this. So first this sequence is given, right? So this sequence corresponds to small letter xn, 3, 4, 5, 5. So where the values of there are 4 values given, so we can write the observations, number of observations as n is equal to 4. Also this set is of xn, right? So we can write that this is x0, this is x1, this is x2, and this is x3, okay? If you want, you can write it here separately. x0 is equal to 3, x1 is equal to 4, x2 is equal to 5, and x3 is equal to 5. So now the formula given to find out the DFT, we know that it is capital letter xk is equal to summation for n tending to 0 to n minus 1 xn into omega to the power nk, right? So here we need to find first we need to find the value of omega, okay? Let's do that first. We know that omega given in the formula is e to the power 2 pi I by n, but the value of n given in this question is 4. So substitute that omega is equal to e to the power 2 pi I by 4. We cancel this 2 1s or 2 2s are, the remaining is e to the power pi I by 2. So this is again of the form e to the power I theta, right? And the e to the power I theta is given as cos theta plus I sin theta, okay? So here in the place of theta we have pi by 2. So what is the resulting we are getting here? Cos pi by 2 plus I sin pi by 2. So now substitute the value of cos pi by 2. You know cos pi by 2 is 0 plus I into sin pi by 2 is 1. So we are getting the final value of omega is equal to iota I, right? So now we need to substitute this omega value in this equation, that is equal to summation n tending to 0 to n minus 1. The value of n here is 4, so 4 minus 1 xn into the value of omega we got is I to the power n into k, okay? Yeah, so now we need to solve this. Xk is equal to summation of n tending to 0 to 4 minus 1 is 3 xn I to the power n k. So this is our general equation. So now in this we need to put the values for k as 0, 1, 2, 3 to find the discrete Fourier transform, okay? So since there are 4 values given, so we need to substitute the value of k 4 times starting from 0. So now first we need to put the value of k is equal to 0 to find x naught, okay? If you put k is equal to 0, the corresponding value here is x naught, right? So x naught is equal to summation n tending to 0 to 4 minus 1 is 3 xn into I to the power n into 0, right? The value of k is now 0. So x naught is equal to summation n tending to 0 to 3 xn I to the power n into 0 is 0, and anything to the base to the power 0, we know that it is equal to 1. So now finally we get the value of x naught is equal to, now remove the summation. We know that the value of n tends from 0 to 3. So now we need to, after removing the summation, we get it as xn into 1, that is equal to xn. So we get it as xn. So first we need to put x naught plus x1 plus x2 up to x3. The value of n tends from 0 to 3, right? So now we know that directly in the question only itself they have given the values for x0, x1, x2 and x3. So now substitute them. 3 plus 4 plus 5 plus 5. So while adding them we will get the first value of x0, that is 5 plus 5 is 10, 10 plus 4 14, 14 plus 3 17. See, the first value of x0 we have got by putting the value of k equal to 0. So now again put k is equal to 1 now. So now when we put k is equal to 1, the corresponding value we get is for x1, summation n tending from 0 to 4 minus 1, that is 3 again, xn, omega value is I to the power n into now the k value is 1. So x1 is equal to summation n tending from 0 to 3 xn into I to the power n into 1 is equal to n. So now remove the summation, so the corresponding set we get it as x, first value is x0, right, 0 to 3, right, x0 into I to the power 0 plus x1 I to the power 1 plus x2 I square plus x3 I cube, right. So now we need to solve this. I to the power 0 is a 1, right, so x0 into 1 is equal to x0 plus x1 into I plus x2 I square plus x3 I cube. So now we know that the value of I square is equal to minus 1, right, and also we can write I cube as I square into I. So again we know that here the value of I square is minus 1 into I, so the corresponding value of I cube we get is equal to minus I. So now let's write them here. So x0 plus x1 I, so I square is minus 1, so now x2, this x2 will become minus x2, right, and again the value of I cube is minus I, so minus x3 into I, right. So now again same thing, we need to substitute the values for x0, x1, x2 and x3. The value of x0 is 3 plus 4i minus 5 minus 5i. So the value of x1 we get is, first add the numbers, 3 minus 5 is minus 2, minus 4i minus 5i is equal to minus I. So this is the value we got for x1. So similarly put the values for k is equal to 2 and 3, then find the values for x2 and x3. So now put the value of k is equal to 3, so the corresponding value we need to find is for x3. Again it is summation n tending to 0 to n minus 1, that is 3, xn into I to the power n into three. Okay, yeah, so I've skipped the k is equal to 2, I've skipped it. After this I'm going to do it. Okay, yeah, x3 is equal to n is equal to 0 to 3 xn into I to the power 3n. Okay, so the same thing again, remove the summation, first value is n is equal to 0, I to the power 3 into 0 plus x1 I to the power 3 into 1 plus x2 I to the power 3 into 2 plus x3 I to the power 3 into 3. So now x3 we get is x0 into I to the power 0 plus x1 into I cube, 3 into 1 is 3, x2 into I to the power 6, 3 to the 6 plus x3 into I to the power 9. So now we need to make some substitutions, that is we know that I0 is equal to 1 and we can write I cube is equal to I square into I, where the value of I square is minus 1 into I. So I cube we can substitute it as a minus I. So similarly I to the power 6, we can split it and write as I cube into I cube, that is again minus I into minus I minus I into minus I is again I square, and we know that I square is equal to minus 1. So we can write I to the power 6 as minus 1. Similarly, I to the power 9 can be written as I to the power 6 into I to the power 3, right? Yeah, so again I to the power 9, I to the power 6 is minus 1, and I cube we got it as minus I, so I to the power 9 it corresponds to plus I. Okay, so these values we can substitute in these equations. So now x to the power 3 can be written as I to the power 0 is 1, so x naught remains, plus x1 into value of I cube is minus I, plus x2 into I to the power 6 is minus 1, plus x3 into I to the power 9 is equal to I. Okay, so now the same thing, x naught minus x1 I minus x2 plus x3 I. So now substitute the values for x1 naught, x1, x2 and x3. X naught is 3 minus 4i minus 5 plus 5. So x3 which we are getting here is now 3 minus 5 is minus 2, minus 4 plus 5 is equal to plus 1, so minus 2 plus I. So this here we got the values for x3. So now we have left with left x putting k is equal to 2, right? So now we'll do that. Okay, so we didn't find the value for x2. First we'll find that. Actually first we needed to find this, after that this, so I've skipped that, so I'm doing it again. So n equal to 0 to 3 xn into I to the power 2n right now. So x2 is equal to, remove the summation, x0 into I to the power 2 into 0 plus x1 I to the power 2 into 1 plus x2 I to the power 2 into 2 plus x3 I to the power 2 into 3. Okay, so now substitute the values. This is I to the power 0 plus x1 into I, 2 ones are 2, so I square, x2 into I to the power 4, 2 to the 4, x3 into I to the power 6. So again now we know that I naught I to the power 0 is equal to 1, so this is equal to x naught plus x1 into I square is minus 1. So now we know that I to the power 6 we have found it here, that is minus 1. See, we don't know I to the power 4, so we can write I to the power 4 as I square into I square, right? I to the power 4 is equal to minus 1, I square is minus 1 into minus 1, so I to the power 4 which we get is equal to 1. Okay, yeah, so x2 into x2 into 1 plus x3 into minus 1, so x0 minus x1 plus x2 minus x3. So now substitute the values for x0, x1, x2 and x3. 3 minus 4 plus 5 minus 5. So the value of x2 which we are getting is now 3 minus 4 is minus 1, minus 1 plus 5 is plus 4, and 4 minus 5 is minus 1. So now we have found the values for x0, x1, x2 and x3. So now we'll write the discrete Fourier transform sequence, that is we needed to find capital X to the power k, right, which is equal to x0, x1, x2, x3. So the final sequence which you are getting here is, what is the value of x0? 17, x1 minus 2 minus I, x2 is minus 1 and x3 is minus 2 plus I. So this is your required discrete Fourier transform sequence. So now using this, where this corresponds to x0, this is x1, this is x2 and this is x3, right? So using this, now we need to find the inverse of this sequence. Okay, inverse discrete Fourier transform. We should remember that after doing the inverse discrete Fourier transform, the answer we should be getting here should be the same as the given question, that is 3, 4, 5, 5. Okay, so the inverse of this Fourier transform would be giving the answer that only. Okay, yeah. So now using this sequence we need to apply the inverse discrete Fourier transform. Yeah, so now we know that in order to find the inverse discrete Fourier transform, the formula given is small letter xn 1 by n, where value of n here is 4, summation of k, now k tending from 0 to n minus 1, capital Xk, where the value of omega is I to the power minus nk now. Okay, yeah. So the same thing again we are going to apply it again. Xn is equal to 1 by the value of n is 4, summation of k equal to 0 to 4 minus 1 is 3, xk minus nk. So now first we need to put the value of n, now n is equal to 0 to find x naught. Okay, to find x naught, but we know that in the question we have already derived that the values of x naught, x1, x2 and x3 are 3, 4, 5 and 5. We need to get these values only as the answers. Okay, so now let's check that we are getting that or not. So first for x naught, formula is the same, 1 by 4, k is from 0 to 3. So now the value of this becomes 0, right? Capital X naught, capital Xk into I to the power minus n into the value of k now is 0, right? So now we need to remove this summation, that is x naught is equal to 1 by 4 into, so now substitute the value of k from 0 to 3, that is this we know that I to the power n into 0 is I to the power 0, that is equal to 1. So the left out term here is 1 by 4 summation k tending from 0 to 3 x k. Okay, so now while we substitute we get it as x naught, the values of k is from 0 to 3, so x naught plus x1 plus x2 plus x3. Okay, yeah. So now x1 by 4 plus, substitute the values for x0, x1, x2 and x3, that is 17 plus minus 2 minus I plus of minus 1 plus the value of x3 is minus 2 plus 7. So now simplify this, 17 minus 2 minus I minus 1 minus 2 plus I. So we can see that this minus I plus I gets cancelled. So x naught is equal to 1 by 4 into, add these terms, 17 minus 2 is 15, 15 minus 1 is 14 and 14 minus 2 is 12. So again 4 1s are, 4 3s are. See, we are getting the value of x naught as 3. Correct, right? The value of x naught is 3 only, right? Yeah. So now put n is equal to 1 and find the other values, that is x1 is equal to 1 by 4 from k tending from 0 to 3 xk I to the power minus n into 1 right now. Okay, so x1 would be 1 by 4 k tending from 0 to 3 xk into I to the power minus n into 1 is n, right? So x1 is equal to 1 by 4 into, so take this summation sign, that is x naught I to the power minus 0 plus x1 I to the power minus 1 plus x2 plus x3 I to the power minus 3. Okay, so this x1 is now 1 by 4 into, so again I to the power minus 0 is 1 only now, so x naught plus x1, bring I to the power minus 1, bring to the denominator, so it will be x1 by I plus x2 by I square plus x3 by I cube. Okay, 1 by 4 x naught. So here plus x1 by I, keep it as it is. So we know that I square is minus 1. So if it is minus 1, so now this would become x2, right? Minus, this plus sign will change to minus since I square is minus 1. Minus x3 by I, because I cube is I square into I, and we know that I square is minus 1, so this sign changes to minus. Okay, yeah. So now substitute the values for x0, x1, x2 and x3 again. x0 is 17 plus minus 2 minus 2I by I minus of minus 1, right? Minus 2 plus I by I. Yeah, so now we need to solve this. So we know that in these two terms the denominator here is I, so we can make this denominator I square so that we can eliminate this, right? We know that I square is minus 1. So in order to make this denominator I square, we need to if we do this as I square, we need to multiply the numerators by I, okay, for these two terms, okay, so that we can substitute the value of I square as minus 1 and this denominator goes. Yeah, so now we are going to doing that only now. 1 by 4, multiply numerator and denominator by I for this term and this term. So now if you multiply numerator by I, this would become I square, and I square is minus 1, so this plus sign changes to minus now. So minus 2I minus I square, right? Minus into minus is plus 1, and this sign changes to plus since the denominator I square, minus 2I plus I square. Okay, so now we are going to simplify this. So now x1 would be 1 by 4 into 17. There is a minus sign outside, so minus into minus is plus 2I plus I square plus 1 again minus 2I plus I square. So we know that I square is minus 1, substitute that. 17 plus 2I minus 1 plus 1 minus 2I minus 1. So plus 2I minus 2I gets cancelled. x1 is equal to 1 by 4 into, so minus 1 plus 1 goes, so 17 minus 1 is 16. So that is 4 1s are 4 4s are. So see, we got the value of x1 is equal to 4, right? So now in the same way we are going to find x2 and x3. Yeah, so I have substitute the value of n as 2. If we substitute n as 2, we get it as I to the power minus 2n. Sorry, this is minus 2k, okay? So here also this is k, okay, since the limit summing is from k, right? Yeah, so this is k, okay? Yeah, so x2 would be 1 by 4. So now remove the summation. Now it will be x0 I to the power minus 2 into 0 is 0 plus x1 I to the power minus 2 into 1 is minus 2 plus x2 I to the power minus 4, right? I to the power minus 6. So now x2 would be 1 by 4 into I to the power 0 is 1, so x0 plus x1 by I square. So I bring this to the denominator, x2 by I to the power 4 plus x3 by I to the power 6. x2 is equal to 1 by 4 into x0, I square is minus 1, so this sign changes to minus 1, and I to the power 4 is I square into I square, that is minus 1 into minus 1 is again plus 1, so this remains as it is. I to the power 6 is again minus 1, so this would be minus x3. So now again substitute the values for x0, x1, x2 and x3. x0 is 17 minus of minus 2 minus I plus minus 1 minus of minus 2 plus I. So now solve. So multiply this minus, so minus into minus plus 2 plus I minus 1 plus 2 minus I. Plus I minus I goes 1 by 4 into 17 plus 2 is 19 plus 2 21 minus 1 is 20. 4 ones are 4 5s are. So the value of x2 we are getting here is 5. Similarly find x3. Yeah, so now we find x3. I substitute the value of n as 3. So in the place of n it is now 3k. So remove the summation. I have written 0 minus 3 minus 6 minus 9. So now x3 is equal to 1 by 4 into I to the power 0 is 1, x1 by I cube plus x2 by I to the power 6 plus x3 by I to the power 9. Okay, 1 by 4 into x naught, I cube is I square into I and I square is minus 1, so this would be now minus x1 by I plus I to the power 6 is again minus 1, so this would be minus x2, and I to the power 9 is I to the power 6 into I cube, that is minus 1 into, that is equal to minus I. Minus 1 into minus I, that's equal to plus I. So the value of I to the power 9 is plus I, so this would be x3 only. Yeah, I to the power 9 we are getting it as plus I, so plus x3 by I. So now the same thing again, here I and I are there, so substitute the value of x1 x3 and multiply the numerator and denominator by I square so that we can cancel them out. Yeah, so here multiply the numerator and denominator in these terms by I, 17, so this becomes I square, the sign changes to plus, minus 2I minus I square, minus into minus is plus 1, again this changes to minus, minus 2I plus I square. So x3 will be 1 by 4 into 17 minus 2I and minus I square plus 1 plus 2I minus I square. So minus 2I plus 2I gets cancelled. 1 by 4 into 17 and the value of I square is minus 1, so since there is minus I square, so it becomes plus 1, and again this is again plus 1. Right, 1 by 4 into 17 plus 1 plus 1, that is equal to 20. 4 1s are 4 5s. Again the value of x3 we are getting it as 5. So the inverse discrete Fourier transform sequence is for x to the power n, that corresponds to x0, x1, x2, x3. So the final answer for x to the power n we are getting it as 3 4 5 5, which is the given question itself, right? So this is your inverse discrete Fourier transform. Okay.